Micro and nanoplastics damage the heart and blood vessels. The main thing electrostatically charged nanoplastics do is they destroy the mitochondria inside our cells. The heart is one of the body's most energy-demanding organs, and it's the mitochondria, the energy producers, that give it the power for every single beat. And when mitochondria start to malfunction, the heart literally stalls. It no longer has enough energy to maintain a normal rhythm or strong contractions. Heart attacks and strokes remain the world's leading causes of death among all diseases. In this context, it's especially alarming that scientists have found micro and nanoplastics inside atherosclerotic plaques, dense deposits within arterial walls that narrow the vessels and can obstruct blood flow. When a vessel becomes constricted or a clot forms, blood circulation to the heart or brain is disrupted, sharply increasing the risk of a heart attack or stroke. Research shows that when microplastics are present in carotid artery plaques, the risk of these life-threatening events and fatal outcomes rises by 4.5 times. Micro and nanoplastic particles trigger blood clot formation. When micro and nanoplastics enter the bloodstream, they don't simply drift there passively. Because of their electrostatic charge, plastic particles stick to vessel walls and attract blood proteins and cells. These coated particles damage the endothelium, the ultra-thin layer of cells lining the inside of blood vessels. The endothelium is like an intelligent shell of the vessels. It regulates their dilation and constriction, controls blood clotting, and protects against inflammation. However, under the influence of micro and nanoplastics, this system breaks down, leading to chronic inflammation and an increased risk of thrombosis. In addition, electrostatically charged microplastics can interact with blood cells, platelets and red blood cells, disrupting their normal behavior. Under normal conditions, red blood cells carry a negative surface charge called the zeta potential, which keeps them from sticking together and allows blood to flow freely, even through the tiniest capillaries. But when exposed to microplastics, this charge decreases. Red blood cells begin to clump together, blood viscosity rises, and clot formation starts. As a result, clots appear in the vessels, obstructing blood flow, which is especially dangerous for the brain, heart, and eyes. This consequently increases the risk of chronic fatigue, vision disorders, hypertension, heart attack, and stroke.
Nanoplastics interact with cell membranes. Positively charged nanoparticles are strongly attracted to negatively charged components, leading to disruption of membrane integrity, for example, in red blood cells, platelets, and endothelial cells.
Micro and nanoplastics induce the development of cancer.
The rise in cancer rates worldwide is absolutely frightening. I think it's very legitimate to call it an epidemic. The statistics are sobering. The World Health Organization estimated that in 2020, worldwide there was about 18.1 million new cases of cancer, whereas in 2022, just 2 years later, it's gone from 18.1 million up to nearly 20 million. And in fact, according to the World Health Organization, if this trend continues, by 2050, worldwide there's going to be 33 to 35 million new cases of cancer, truly an epidemic and truly a real major health issue affecting every single person everywhere in the world. So yes, that's a huge problem.
For a long time, cancer was considered a disease of old age, the result of accumulated DNA mutations, weakened immunity, and years of exposure to carcinogens. But today, because of nanoplastic exposure, mutations can begin to build up in the body at much earlier stages of life.
There's an increased rate of cancer worldwide in children and also in people much younger than I used to see. So what's going on now is that we're having a rise in people getting cancer, children, young adults, and it's probably not due to smoking or alcohol or anything. There seems to be something else, something in the environment that is causing this cancer at an alarming rate, and it's getting worse. So a very serious problem, yes. And again, one of the possibilities that could be accounting for this, we'll be talking more about it, is indeed nanoplastics.
We observe in the last 30 years that in some countries we observe early onset cancerogenesis, so that tumors are diagnosed more early than previously. So that was like colorectal cancer are observed earlier than and diagnosed earlier than 30 years ago in average.
A key role in tumor development may be played by mitochondrial dysfunction, caused by exposure to nanoplastics. This happens through the accumulation of mutations in mitochondrial DNA and the disruption of normal cell death mechanisms, which together reduce the body's ability to eliminate damaged cells and increase the likelihood of these cells transforming into tumor cells.
So these tumor cells are very aggressive, and normally they don't take anything up which they cannot use. So, I mean, what could happen? I mean, this is hypothetically that they can produce some energy out of these plastics, or somehow some pathways are activated which are helping the cells to move faster. That could be. So we need to investigate that. So it's a very important question, and we are basically on that to find out what happens mechanistically in those cells, that they can use plastics to facilitate their microglial potential.
Nanoplastics increase levels of reactive oxygen species in organ cells and tissues, causing oxidative stress that accelerates the growth of cancer cells, helps them spread to other tissues, stimulates formation of new blood vessels, enhances inflammation, and weakens the immune system. Moreover, the high level of oxidative stress caused by electrostatically charged nanoplastics promotes the survival of tumor cells and reduces their sensitivity to therapy, making malignant cells more aggressive.
Anything that damages the normal cell DNA that is responsible for the growth and division of cells, that damage can contribute to that cell becoming malignant, growing and dividing and spreading uncontrollably. That's what cancer is. And that is certainly a concern about the effect of nanoplastics. And then above and beyond that, because nanoplastics affect so much of the cell's function, the oxygenation, the ability of a cell to function, above and beyond that, I'm concerned as a doctor that treats cancer that nanoplastics may be reducing the effectiveness of our cancer treatments. I'm a physician that treats cancer with radiation therapy, so I am concerned about nanoparticles adversely affecting the use of radiation therapy to control cancer. And there's actually been some preclinical research on this that does suggest that the nanoparticles, and certainly contributed to by the typical negative charge that they have, in addition to adversely affecting cells, can actually reduce the effectiveness of radiation therapy. There's certainly a significant theoretical reason to believe that the nanoparticles may reduce the effectiveness of cancer treatments, not only my modality of radiation therapy, but certainly I have the same concern about it reducing the effectiveness of chemotherapy or other systemic treatments or immunotherapy.
Research by the Medical University of Vienna has shown that micro and nanoplastic particles remain inside cells far longer than previously believed, as they are passed on to newly formed cells during division. In addition, there are also early indications that these plastic particles may play a role in tumor metastasis.
So that's one of the problems, that the tumor grows very quickly and then also disseminates. And what we observed is that these particles are kept by the cells even after cell division, and then they are helping the cells to migrate quicker, so they can move quicker. And that's a property which we also observe in tumor cells when they are in the body, so that they can move to other places and even metastasize. And so we have to assume that also in the body, that these tumor cells can basically use those plastics to proliferate and move around in the body. When I came to this plastic topic, I thought myself, that this is, we introduce here material which is potentially toxic, potentially accumulating over the years, over the decades of the centuries, so maybe for a very long time, affecting our health, but also the evolution. I not only mean the cancer evolution of how cancers originate, but even the evolution of new species and the evolution of the whole ecosystems.
Nanoplastics affect every system in the human body. They act as a trigger, setting off a cascade of processes that lead to serious illnesses, all because of their electrical charge. Today, we know that nanoplastics play a significant role in the development of conditions that have become the leading causes of death worldwide. It may seem that the humanity has already faced its greatest threats: antibiotic resistance, autoimmune and neurodegenerative diseases, and cancer. Yet, there is something even more frightening than disease itself. Imagine living an ordinary life, feeling healthy, full of energy, going to gym, delivering a presentation, meeting friends. But then, a moment later, one suddenly dies. The body stops functioning as if someone has switched the lights off.